What's up, man? You ready to start learning about radioactivity?
No promises on that one. All these Greek letters are throwing me. Alpha, beta, gamma. I'm pretty sure this is why Bruce Banner is always getting so angry.
Wait, I'm sure learning about radioactivity won't make you go Hulk on us, but maybe you should give a look at that chart your teacher gave you.
An atom is radioactive if its protons and neutrons have an unstable configuration in its nucleus. For lower numbers of protons, the number of neutrons needed for a stable balance is roughly equal to the number of protons. Carbon-12 is an example of this. It is the most abundant form of carbon, containing 6 protons and 6 neutrons. As you get more protons, more neutrons are required for stability. Lead-2O6 has only 82 protons compared to its 124 neutrons. If the configuration of the atom is unstable, then it will undergo radioactive decay to find a more stable configuration of its nucleus.
So if there aren't enough neutrons to balance out the protons, the atom decays in order to stabilize?
That's right. There's a number of ways that the atom can go about this.
In alpha decay, an alpha particle is emitted from the radioactive nucleus. An alpha particle is a helium nucleus composed of 2 protons and 2 neutrons. This type of decay lowers the proton-to-neutron ratio and brings the nucleus to a more stable configuration. Many nuclei heavier than lead have this decay mode. Because the number of protons and neutrons is changing, the daughter product is going to be a different element with different chemical properties. For instance, polonium-210 with 84 protons and 126 neutrons will decay to lead-2O6 with 82 protons and 124 neutrons. Beta decay is another form of radiation that involves the release of a particle. In beta decay, either an electron or a positron, an antimatter electron, is released from the nucleus. This occurs in nuclei with either too many protons or too many neutrons, because one type of nucleon decays into the other. In beta-minus decay, a neutron decays into a proton, electron, and an antineutrino. In beta-plus decay, a proton becomes a neutron, positron, and neutrino.
Hang on. You're telling me that particles can just switch up into different parts like that?
Well, it isn't just switching up. Conservation laws are obeyed in these reactions, such as electric charge and lepton number. For instance, for a neutral neutron to become a positive proton, an electrically negative electron is needed to cancel it out. And for a neutron with lepton number 0 to become a proton with lepton number 0, an electron with lepton number 1, something with a lepton number negative 1 is needed. In that case, it's an antineutrino.
You know, that does make a little more sense. Since everything is conserved like electric charge and lepton number, decay can happen.
Exactly. Now we're going to find out about your favorite type of radiation, Mr. Hulk.
Gamma radiation is different from alpha and beta decay because it is a release of electromagnetic radiation, a photon. A particle goes from a higher energy state to a lower one by releasing a photon. In this case, the number of protons and neutrons stays the same, so the element does not change. The only change is the atom goes from being metastable to stable. One last thing. All radioactive isotopes have a half-life. After one half-life passes, half of the radioactive sample will have decayed to the daughter product, and half will remain the same. As more half-lives pass, you will have a fourth of the sample staying the same, then an eighth, then a 16th, and so on.
You know, this is starting to make sense. Particles decay in different ways to help stabilize themselves. This is definitely way easier than I thought.
Next time, we can talk about different applications of radiation.